All right, here's our Newton's second law word problem. So there's going to be math involved. And the general scenario will always be that there's going to be an unbalanced overall force, total force, that makes the object accelerate. That's the big idea with Newton's second law. So, reading the question, we've got a 5-kilogram box is pushed across the floor by a person applying a 20 Newton horizontal force. Calculate the acceleration of the box if there is a 10 Newton force of friction. So with word problems in the past, we would do our KU charts. If it's a problem involving forces with Newton's laws, we actually are going to draw an FBD. All right, so right here, if you want to label it, here's an FBD. If you kind of think of this scenario, well, first of all, it's going to be on Earth, so we know there's a gravitational force pulling it down. This is, again, what we call weight. It's not the 5 kilograms, that's a mass, but there's a relationship at least that we can use to solve for the weight. And if it's being pushed across the floor, it's pretty much going to be on a horizontal floor, so there's going to be a normal force. Remember, that's from surfaces like floors. It's called normal because it's perpendicular to the surface, so let's assume the floor is horizontal, it's flat. Okay? Here comes the big stuff though. The person is applying a 20 Newton horizontal force. So when it's from a person, we call it an applied force because that person is applying a push or a pull on the object. The other thing that's stated is there's a force of friction. Basically the idea, if you think about it, if you try to push this object to the right, friction always opposes motion. So since the person's pushing to the right, this force of friction is going to be to the left. So I'm going to make it a point to actually draw the 10 newtons smaller, which since I gave you the numbers, that should be pretty clear that it's smaller in magnitude, but you have to know it's to the left. Okay? So I'm definitely making sure that my x component forces, the ones I have values for, I'm making sure that those are pretty close to scale. My y are not to scale. I'm not going to get too concerned about that though with this problem because they're not really going to apply. Anyway, let's set up the big ideas. All right, we do have forces in 2 dimensions, 2 components. And the acceleration, if you think about the scenario, is coming from a person pushing to the right. So I would think my unbalanced total force is to the right, which is shown in the FBD, which means the acceleration is to the right x component. All right, now out of habit, just for the sake of future problems, I'm still going to focus on the y component. And if I think about the sum of the forces in the y component and what it's doing vertically, well, it's not moving at all. When I push a box across the floor, it doesn't move vertically. So there is no acceleration in the y, which means I should apply Newton's first law in the y. All right, I could, of course, set up the forces in the y component then and just have the blueprint ready. I just want to have that for the puzzle in case I need to use it. All right. Sorry, I missed that out. That's the y component. All right, here's the big one though for this problem. It's the x component. The object, if it's being asked, what's the acceleration, is probably going to accelerate. So I'm thinking Newton's second law. I also know the values of the applied force and the force of friction in the x, and I know that they're not the same, so this is definitely unbalanced. So that's again confirmation that I am going to be solving for an acceleration in the x component because the forces in the x component are unbalanced. All right. Once I do this, same thing I did with the y, I want to identify what forces are in the x component. And there's the force applied and the force of friction. All right, so again, I can do all of this without numbers if I just think conceptually what's going on, and this will give me a very good starting point. This is pretty much half the battle, the FBD, and then recognizing if it's accelerating or not. Of course, y it's not, x it is. So here we go. It asked me to solve for the acceleration, which is of course occurring in the x, so I'm going to try to use Newton's second law in the x component here. The force applied, it's in the x component. I didn't say in the question if it was to the right. I kind of chose it to be to the right, which is okay for this problem, so that would be a positive 20 newtons. What I definitely need to understand though is that friction always opposes motion. So again, if I'm trying to push it to the right, friction should be to the left, which means when I go to do my math, that's got to be in the negative direction. So we've talked about this with vectors. Sometimes you have to figure out directions on your own, actually, and make sure you get those right. All right, the mass. I don't know the weight. I don't know Fg, but they actually just told me the mass. I told you the mass was 5 kilograms. So I don't really need to do anything with my weight equation. I can just plug that in, and then it looks like I can solve for the acceleration because that's the only unknown. All right, of course, simplify. The total force, when I simplify these, will be positive 10 newtons. So that's the sum, net, total, whatever you want to call it. And I see that it's to the right, which kind of makes sense because it's the person that's going to get it to start moving, not friction. And I also like this because if I push something to the right from rest, I'm probably going to get it to accelerate to the right. And we've learned that, well, if the total force is to the right, the acceleration has a direct relationship with that, so the acceleration should also be to the right. So that essentially means I should get a positive acceleration as well if my total force is positive, which I will, because mass is scalar, there is no direction. And of course, when I divide these, I get an acceleration of 2. But recall your units, a Newton, if you've forgotten, is equal to a kilogram times a meter per second squared. So if you want to just replace newtons with that, when I divide by a kilogram, of course the kilograms cancel and I'm left with meters per second squared, which is the unit for acceleration. So again, this kind of makes sense. If the overall total force is to the right, the positive x direction, we learned that there's a direct relationship between total force and acceleration, where my acceleration should also be to the right in the positive x direction. All right, pretty straightforward. It could have been a little bit easier if there wasn't friction, but I don't think that's too crazy to start off with that idea to begin with, okay? All right. Again, this is our foundation. Problems will get harder beyond this, but always think about the building blocks with Newton's first law and second law, of course, whichever applies to the scenario with the FBD.